So far, when I've showed you all the different types of synthesis, one of the most simple ones was the subtractive one, where the sound coming from the oscillator was being filtered by a filter. Now today, we get into these filters and filter types. The one I'm going to start with is the one that I always used in the examples so far. It was the low pass filter. So I'm going to engage the filter. It will be the low pass filter. And why is it low pass? Well, I'm going to show you right now. I will play this sawtooth. Even if I play a lower note. So you can see that the shape of this graph right here coincides with the change being done to the sound in the spectral domain. So what the filters do, they shape the spectrum of the sound. The low pass filter lets the low frequencies pass, hence the name low pass. There is another name for it, which is called high cut. It actually cuts off the high frequencies and lets the low frequencies pass, hence the two names, low pass or high cut. And you will find both of those names present in VST plugins and hardware equipment. But a low pass filter does what the name says, lets the low frequencies pass below some point. That point is determined by the cutoff frequency. So this is the central cutoff frequency for that filter. And below that point, all the frequencies can pass. Above that point, the frequencies are being cut off. Now, this filter can cut them off more steeply, like that, or even that. Let's listen to that. So we have different types of low-pass filters, depending on how steep they cut after the cutoff point we set. So a low-pass filter cuts off all the frequencies above the cutoff point at certain steepness, of course. Now, what do these numbers 6, 12, 18, and 24 mean? Well, those give us the number of decibels per octave that we are cutting. So if I go right here up to, let's say, 1000 hertz, that's 1 kilohertz, that's right here, and I play it. This slope right here from 1K to 2K, which is 1 octave, double the frequency, we talked about that already in lessons past. So in that 1 octave, the volume is being cut down by 24 decibels. So each octave, 24 decibels down. And then up to 4K, again, another 24 decibels down, and so forth. Same for this one, 18 decibels per octave, 12 decibels per octave, and 6 decibels per octave. Now these filters are also called a 1-pole, 2-pole, 3-pole, and 4-pole filters, meaning that 1 pole is that 6 dB attenuation per octave. We will encounter these in different synthesizers, so it's just different names to the same thing. Now, another really important parameter we have for a filter is the resonance. The resonance is the amount of boost the filter gets on its cutoff frequency point. Right there, where we start cutting off, if we do a resonance boost, we'll get a peak right before it starts gliding down. That gives us a characteristic sounding, whistling, resonant sound, and hence it's called resonance, of course, because it's upping the resonance. It gives us a resonant sound just before the cutoff point. Let's hear that. So you see it kind of whistles at that point where the actual cutoff frequency is if we up the resonance. Now let's see what other types of filters do we have. We have a high pass filter. A high pass or a low cut filter is exactly the opposite of the filter we just seen. So this one lets the high frequencies pass or cuts off the low ones. And again, we have the different slope filters right there, and we have the resonance settings. Let's hear this one. And you might have recognized that sound from so many songs because filters are what's mainly used in music production on synthesizers and also in acoustic music. So filters are one of the main things. And I'll tell you why, because every equalizer that is used to control spectrum, response, and we talk a lot more about equalizers when we get to our audio processing course. For now, equalizers are just an assembly of different filters. That's it. Here we're dealing with one filter. Equalizer is just a collection of filters together that is used to control the spectrum. Now we have the high pass or a low cut filter, hence the two names, high pass or low cut. You will encounter both of those names. We also have a band pass filter. A band pass filter is actually a combination of the low pass and high pass filters together in serial. So we have the low pass and we have the high pass at the same time. Starting from the central frequency we choose, we can also up the resonance, and this is what it looks like. So it's cutting off all the frequencies above and below this center frequency. So it only lets one band of frequencies pass, hence the name band pass. Now we also have an opposite of that filter, a notch filter, which is actually not letting one band of frequencies pass. Let's hear what the notch filter sounds like. And also by upping the resonance, we introduce how much we want it, wide or narrow. Of course, we can change to a notch 12. And one more filter right here that we need to talk about is the peak filter. Now, the peak filter is also really common in EQs because it only boosts one certain band of frequencies, but it does not cut off everything around it, just boosts one band of frequencies or attenuates it. But we're going to talk about the boosting right now. So we're going to boost that part. See, just boosted, nothing cut. So that's the peak filter. Now, these filters, low pass, high pass, band pass, and notch, are actually the main types of filters. Now, the reason I have chosen Serum to show you all of this, because I have this nice graph of the filter, what it does, and you can identify that on the actual spectrum analyzer. We can go into more special types of filters. Now, first, in Serum, we have combinations of filters. We have, let's say, a low pass and a high pass filter, like that. So we have two of them. See that? High pass and a low pass. Now, how is this different from a band pass? Well, in the band pass filter, we couldn't control them separately. We could just have this and then move them together so we get that band pass all the time. Now, this way, when we have them in combinations, we can actually move them separately and give them a wider area of effect, like that. And we have many more combinations, like a low pass and a band pass filter together. So just like that, that's a band pass filter, and on top of that, we have a low pass filter that's going to be added on top of it. So combinations of those also are included in Serum, and we have some crazier filters like comb filters, flange filters, phaser filters. Now, all of these contain, let's say, a comb filter, a lot of notch filters. You see that? And they begin to be like more dense and more dense. So a combination of a lot of notch filters is what gives us a comb filter. Listen to that. See, it looks like a comb for combing your hair. So hence the name comb filter. We have flange and phase filters, so different types of special filters that produce, let's say, a phasing effect as a phaser would. And we will talk about the phaser in our audio processing course. as you can see, it also introduces some notch filtering, some peak filtering, combinations of filters, which gives it a really distinct sound of flanging. So comb filters, flanging filters, phasing filters, and miscellaneous, which is like special types of filters. And one of those I want to mention is going to be the Foreman filters. Now, Foreman filters produce Foreman kind of sounds like vowels, like a, e, o, u, some of those. And those actually sound like that because our cavities in our throats, mouths, and nose produce that kind of resonance and notches so that we get those sounds sounding like that. So coming out of our mouths, of course. So let's hear what that sounds like. And we have different ones. So this one is a, e, o. That's the one we have. So the next one. Different types of vowels being transformed from one to another. So these are nothing else but collections of filters, so notch and bandpass and low pass, high pass filters that work together to give us an emulation of what our vocal apparatus would actually produce once we utter these vocals. Now let me show you the similarities these filters have with the filters in other synthesizers. So let's find Massive. So here in Massive, you will see that amongst the filters, we have a low pass, high pass, all pass, double notch, band pass, band reject, scream, daft, comp, acid. So those are all different kinds of special filters, also the main, normal ones. And let's see the low pass 4, what that sounds like. So see all the same controls, cutoff, resonance, and the type of filter. This one says 4 and low pass 2. That refers to that pole relation I told you about. So low pass 2 would be a 12 dB per octave low pass filter, and low pass 4 would be 24 dB per octave filter. So one pole, 6 dBs per octave. Same for the high pass. And of course, some special filters like the comb filter I showed you in Serum. Again. And then we have some special ones like, let's say, the band reject, which is actually almost like a notch filter, but not all the way down. We also have a double notch filter. So you see that two notches following each other. So two notch filters in series, and we control them both using this. So some special types of filters, which are actually combinations of those basic ones. Now you can find these types of filters in many equalizers as a collection of filters that actually comprise one equalizer that controls the spectrum response of the sound.